Hello, my name is Dr. Thomas or Dr. T, and I am teaching one of the sections of 104. I'll be developing these videos all semester long to go with your homework. And I would love your feedback because as we're doing these videos, you can imagine that we think we're doing a good job, but we may be able to improve or do better. So this is my email, which I'll be giving several times as I'm developing these videos, and that's my mobile phone number, so you can text me about questions you may have or gaps you see in my explanations. Best is if you post in the YouTube video site directly underneath in the comments and say, you know what, I really would have liked to see this particular step, or I didn't understand when you did X. All right, let's get going. What I'm doing is similar problems. I'm not doing exactly the same problem, but I try to go and do something that's pretty close. And if there are differences, I'll point them out. So starting here, we have a graph, and it's not typically how we do things. We don't have a function explicitly written out, but it's drawn here. Studies actually have shown that students don't think this is a function. It is a legit function. It's what we call a piecewise defined function. So it's defined in pieces. And you are asked first to find these f at 0, f at 1, f at 2, and f at 3. I think yours has a g in it. I made this one up. I pulled it from the internet somewhere, a picture, so that I could make something up that's similar. All right, so how do I do that? Well, first, if it doesn't look like the way I'm used to seeing things, I'm going to make it look like the way I'm used to seeing things. So typically, we have x's and get y's. That's why you're in college, to get y's. And you pull out the x's on the x-axis. 0, 1, 2, and 3 are the x values. And you're looking for these y values. And I'm going to have to get that from the graph. So first of all, I go to 0. X equals 0, the graph is intersecting at 0. So I get 0, 0. And so forth. At x equals 1, I have 1. At x equals 2, well, it looks like it could be 2, but you see this hole here? This hole means that 2 is not included. And actually, I have to go up a little higher where I have this colored in circle. That means that y equals 3 is actually the y value for x equals 2. So not that one, but that one. So here I get at x equals 2, y is 3. X equals 3 is a little bit easier. I get 3. Next question. For what values of x is y equal to 3? I say y because that's the way I'm used to seeing things. So I'm going to repurpose or redesign the problem in the way that I understand it. So if I just look at y equals 3, what does y mean? Well, it's where you think of y as being an elevator. So the elevator is going up and it stops at 3. And you're looking at floor number 3 and saying, which x values gave me a y value that actually landed it on the floor 3? Since I pulled this from the internet, I don't have it actually crossing right at -2. I'm going to pretend it did, but it's close enough. Right around close to -2, it crosses. So almost -2. And also, it crosses again, not at 1, x equals 1. There's a hole there. But right after 1, I see that it's all on floor 3 up to 2. And then it's again on floor 3 at 3. So the way we write that is we say single curly brackets -2. That means it crosses at -2. It also crosses from x equals 1 to 2, but 1 is not included. So 1 is not included, I put a parenthesis, and then I go 1 to 2 and close that parenthesis with a square bracket, meaning that 2 is included. So from x equals 1 to x equals 2, but 2 is included and 1 is not. And then again, I have a single 3, x equals 3, again crossing. So that's what I do for this part. I'm going to stop here and continue this on the next piece so that it's actually, I'm only allowed 5 minutes, and that's pretty good, a good place to pause.